Okay, good morning all. Is it visible to all? Is it visible? Okay. Okay. So I think we start with data transfer. So at the end, we gone through this, right? Push and pop, which is used to push the contents on stack, right? So whatever you mentioned here, whether it is register or anything, right? Or you can say any register, that content of register is pushed or stored onto stack. Likewise, pop is used to extract the content from stack. One more important instruction, or which is favorite of all external examiner, is push PSW, right? Program status, right? Program status word. What does it mean? Accumulator plus flag register. Combination of this is called program status word, right? So content of accumulator and content of status register, or you can say flag register. A combination of both this is called program status, right? So this is basically higher order and flag register is lower order, right? While treating this, right? So this basically is stored on, or you can say content of accumulator and a flag register is stored in stack memory, basically. Right? जसं pop PSW तसं sorry push PSW तसंच pop PSW, right? So extract the content, right? So higher order पहिल्यांदा place करतात, lower order नंतर pop करताना lower order पहिल्यांदा, higher order none, right? So that is the sequence. Just write down, how actually instruction executed in case of push and pop. So first step is the content of SP is decremented by 1. The content of SP is decremented by 1. Then second, the content of high order register is moved to memory addressed by SP. The content of high order register C. Suppose B, C is my pair. Then in case of this, B is high order, C is low order register, right? So first the content of high order register is moved to SP, memory addressed by SP. Then content of SP is decremented by 1. Again, see, this is, if this is my stack memory and stack top is pointed out somewhere here, it is decremented, right? Decremented म्हणजे का? तर मी सांगितलं तसं मेमरीच्या एंडला असते. सो तुम्हाला फ्री मेमरी लोकेशन्स कसे मिळणार आहेत? तुम्ही डिक्रिमेंट करत गेला, वरती गेलात, इन दॅट केस ओनली यू विल गेट दी फ्री मेमरी लोकेशन, राईट? जनरल ट्रेंड तुमचा स्टॅकचा कसा आहे की यू विल इन्क्रिमेंट करता, पण तुम्ही दाखवताना स्टॅक उलटाच दाखवता. स्टॅक तुम्ही डेटा स्ट्रक्चरला उलटाच घेता, खाली टॉप घेता, ड्रॉ करताना सुद्धा तुम्ही काय करता, त्याच्यावर टाकत जाता, राईट? So it is basically जरी ते तुम्ही इन्क्रीमेंट करत असेल, इट इज फॉर इझीनेस ऑफ प्रोग्राम की तुम्हाला ते इझी व्हायला पाहिजे. बट बेसिकली यू आर डिक्रिमेंटिंग, तुम्ही पाठीमागत चाललेला असता, राईट. सो ते मेमरीमध्ये एक्झॅक्ट रादर तसंच आहे ते. सो डिक्रिमेंट करतात ते कंटेंट. थर्ड सांगितले का मी, द कंटेंट ऑफ एसपी इज डिक्रिमेंटेड बाय 1 अँड देन कंटेंट ऑफ लो ऑर्डर रजिस्टर इज मूव टू मेमरी ऍड्रेस बाय एसपी. ओके. इन केस ऑफ पॉप काय होईल सांगा. इन केस ऑफ पॉप, इन केस ऑफ पॉप काय होईल. सी डिक्रीमेंट बाय, सॉरी, decrement by 1 higher order, again decrement by 1 lower order, right. That means content which is pointed out, right, by stack pointer is content of low order register. So first you need to extract those content, right. So move the content which are present with stack top, right. Stack top कडे काय असणार आहे, rather stack pointer कडे ना, stack pointer च्या ऍड्रेस कडे जो ऍड्रेस आहे त्या ऍड्रेसच्या मेमरी लोकेशन वर लोअर ऑर्डरचे कंटेंट असणार आहे. सो एक्स्ट्रॅक्ट दोज कंटेंट. सो एक्स्ट्रॅक्ट द कंटेंट ऑफ लो ऑर्डर रजिस्टर फर्स्ट, डिक्रिमेंट, sorry, increment SP by 1, extract the content of high order register, and again increment and जो त्याचे स्टँडर्ड पोझिशनला होता सुरुवातीला तिथंच आणून ठेवला तो, राईट. ला प्रोसिजर इन युअर ओन वर्ड्स. Okay, so this is your instruction. Just tell me how many machine cycles you require to execute this instruction. How many machine cycles are required? Try to calculate. This is for all. Try to calculate machine cycles. How many machine cycles are required? Hmm? का? उभं राहा. काय? मोठ्याने बोल मला. हा, 8. कसे कॅल्क्युलेशन सर? गेस वर चालत नाही. कुठल्या कुठल्या मशीन सायकल्स आहेत मला सांग. हाऊ मेनी मशीन सायकल्स आर देयर? 885. Upward fetch, memory read, memory write, IO read, IO write. Total 5 machine cycles are there. You require 4 T state for upward fetch. All other machine cycles require only 3 T states. That's it. How to calculate? How to calculate? Online वाले आंसर करा पटपट. ऑपकोड कुठला आहे त्याच्यातला? टी शर्ट. मोठ्याने बोल. T is equal to 1 upon F. Okay, this is also correct, but this is for simple formula to calculate time period. Total जे T आहे ना याच्यातलं त्याचा फॉर्म्युला सांगितलं असतो. सी कसं आयडेंटिफाय करायचं? यू नीड टू फाइंड आउट ऑपकोड. आता याच्यात ऑपकोड कुठला असणार आहे? ऑपरेशनल कोड कुठला असणार आहे याच्यातला? येस, एक्झॅक्टली. जी इन्स्ट्रक्शन आहे आणि ती इन्स्ट्रक्शन कुठं तुम्हाला लोड करायची आहे, रादर तो रेजिस्टर. दिस ओव्हरऑल इज ऑपकोड और ऑपरेशन इज ओव्हरऑल इन ऑपकोड ना. ऑपरेशनल कोड मध्ये ते सांगावं लागेल. वाय? बिकॉज डेटा इज ऑलरेडी प्रेझेंट ओव्हर देअर. काय डेटा टाकायचा आहे तो डेटा प्रेझेंट आहे, म्हणजे हा ऑपकोड झाला. राईट, दिस इज माय ऑपकोड. सो इफ दिस इज माय ऑपकोड, दिस रिक्वायर्स 4 T state, right? This requires 4 T state. My data is of 16 bit. My data is of 16 bit. But data bus size is exactly 8 bit. My data is 16 bit. But size of data bus is 8 bit. How many times you need to read this? At least 2. Right? At least 2. This data is basically, you will say, memory leak. That means this, right? So if I require to read this 2 times, how many T states are required? Exactly. How many? 6. For lower order, 3 T states, and for higher order, 3 T states, right? So 4, then lower order, and then higher. How many? Exactly. This is how you need to calculate, right? This is how you need to calculate. Now tell me, for this, tell me for this. See, I'm talking with online students also. So listen carefully what I'm talking and try to guess the answers. This whole is opcode. This whole is opcode. कसं? ऑपकोड कुठला? आणि हा काय आहे? Data. So how many cycles required here? Since it is opcode itself, right? Here, this is your opcode, and this is your 8-bit data. How many T states are required? 3. Since you are reading the data, this is how you need to calculate. Right? समझला आता? Done. So next group is arithmetic instructions. अरे माझा आवाज येते का ऑनलाइन स्टुडंट्स? माझा आवाज येतो? This is my first instruction. Right. So This is what is syntax of instruction. This is what is example, right? So इथं सोर्स मेन्शन केलाय, डेस्टिनेशन मेन्शन केलंय. डेस्टिनेशन आहे का, सोर्स आहे का, कसं कळणार सोर्स डेस्टिनेशन? In case of 8085, if your mnemonic does not give you destination, त्याच्या लेटर पॅटर्न मध्ये त्यांनी जर दिलं नसेल destination, then at that time the destination is always accumulator, right? So add B, right? You need to add content of register B with what? Exactly. So you need to add content of B into accumulator and store your result in accumulator itself. This is the meaning of instruction. So you need to add whatever contents are there in that register with accumulators content and again store that result into accumulator, right? This is how this instruction works. आता हे इन्स्ट्रक्शन किती बाईटचे आहे हे आयडेंटिफाय करता येईल का? आता मशीन सायकल्स मगाशी बघितलं आपण किती होतात, राईट? हाऊ मेनी बाईट्स दिस इन्स्ट्रक्शन? Exactly, 1 byte. Why? Since it is opcode, it is in 8 bits only, right? So this instruction is of 1 byte type. जर डेटा असेल 8 bit, याच्या बरोबर इन्स्ट्रक्शन बरोबर 8 bit डेटा असेल तर त्या इन्स्ट्रक्शनचा 2 byte and instruction with 16 bit data, in that case such kind of instructions are 3 byte instruction, right? हे डोक्यात ठेवायचं. नुसताच लेटर पॅटर्न्स असतील, that means you will have this opcode. आता तुम्हाला हे अंडरस्टँड होण्यासाठी Moodle वर काय करावं लागेल? Moodle वर मी opcode टेबल टाकलाय, राईट? opcode टेबल इज देअर ऑन Moodle. Just go and check that opcode table की तुम्हाला आयडेंटिफाय होईल. opcode table is what? This is simply a conversion, right? Whatever you have mnemonics over there. How many mnemonics are there? 74 mnemonics with 246 flavors, right? म्हणजे काय, तर ऍड असेल तर ऍड ही एक इन्स्ट्रक्शन झाली, राईट? पण त्याचे फ्लेवर म्हणजे काय? ऍड बी, ऍड सी, ऍड डी ना, काइंड ऑफ. सो विथ कॉम्बिनेशन, ऍडिशनचं कॉम्बिनेशन विथ सो मेनी रजिस्टर, हे म्हणजे ते फ्लेवर. सो असं कन्वर्जन इन्स्ट्रक्शन आहे. सो इतक्या सगळ्या, राईट, 246 instructions opcode is present over there. Who gives that opcode? Manufacturer, right? तो डिरेक्टली मॅन्युफॅक्चररने दिलाय. म्हणजे काय इन्स्ट्रक्शन असणार आहेत हे आणि काय ऑपकोड असणार आहेत त्याचे बायनरी पॅटर्न हे दिले ऑलरेडी, राईट? सो दिस इज अबाउट ऍड. The next instruction is एडीसी सांगतो नंतर. एडीआय पहिल्यांदा सांगतो. काय असेल आता हे? Add immediately data present in instruction. Add immediately data present in instruction with exactly accumulator. So सपोज 0 to हेक्स असा काहीतरी डेटा असेल तर अक्युमुलेटरच्या कंटेंट बरोबर अक्युमुलेटर प्लस 0 to ऍड करून परत अक्युमुलेटर रिझल्ट स्टोअर करायचं, राईट? सो दिस इज add m. ओके, आता याच्यात ऍडिशन सांगतो. ऍड दी कंटेंट्स ऑफ मेमरी लोकेशन पॉइंटेड बाय HL पेअर. राईट. ऍड दी location, add the content of memory location which is basically pointed by HL. See, this is 03 with accumulator and store result again in. This is how instruction works. Add with carry and data immediately present in instruction with accumulator store result in accumulator. Right? So accumulator का data मध्ये carry add करायचा plus data which is given over there in instruction and result need to be stored into accumulator. हे काय असेल? Example is ADC. Online student, what is that? Of ADC. Of ADC. Content of accumulator with mentioned register pairs, content of mentioned register pairs in instruction and carry and store result again in accumulator. Last bit. Don't go there. ADCM. Yes. Accumulator plus carry plus memory location. That means content pointed out by HL and store this in him. From accumulator coded in accumulator. So result is there. Subtract data present immediately in instruction with accumulator. Serial register. Subtract with content present in register. That means subtract with accumulator and subtract borrow. Borrow subtraction मध्ये right. Borrow कुठे येतो 85 च्या केस मध्ये जो कॅरी फ्लॅग आहे तिथंच borrow. That means this it is addition. It is treated as carry. If it is subtraction, carry flag is treated as borrow. Right. So result in accumulate. Simple. Yes, BI. Subtract with borrow. Immediately data is present in instruction. So accumulator minus 0 to minus 4 borrow is mentioned as carry. SBDM. BDM म्हणजे तर फक्त काय होणार memory. That means it is pointed out by Excel. So content pointed out by Excel. Accumulator minus content pointed out by Excel minus borrow. Right. So result in accumulator. Again, those are also favorite instructions of external exam. This is that RP. That means if my instruction like DAD, in that case, this content is added into Excel. Right? The content of mentioned register is basically added into Excel. This is what that is. This is simply a 16-bit addition. So, if you want to perform 16-bit addition with x85, then in that case, you load first number into Excel and second number into any other cell, right? And then you can directly add that number by using this, right? So that could be your statement code, right? That instruction is 16-bit addition code, right? So that is will cell मध्ये एक number याच्यात decimal adjust accumulator. Decimal adjust accumulator. That means there is a result inside accumulator. You need to adjust that accumulator in decimal values. Where actually this is used? This is used in BCD addition, right? As and when you have a BCD addition over there, in that case, just to convert that number, right? Whatever number is there in that accumulator, you need to convert it into BCD format. If you want to convert that BCD into BCD format, then you are going to use this instruction. Even though if you are trying a BCD addition inside your program, so after all that addition, you basically perform this operation. So whatever it may be, there in accumulator, this instruction is adjusted in BCD format, right? BCD format मध्ये adjust करतं म्हणजे काय करतं? जर तो number greater than 9 असेल, तर 0110 म्हणजे 6, right? Adjacent factor that you need to add into given or give जो काही result त्याच्यात store आहे accumulator मध्ये, तो possibly जर exceed झाला, if number is exceeded than this, then you need to add, or carry is generated in case of BCD addition, then also you need to use this adjacent factor just to adjacent to correct BCD form, right? हे मी तुम्हाला सांगितलंय की तो number म्हणजे काय होतं, हे BCD नंबर आहेत, याची ऍडिशन किती यायला पाहिजे, 12, right? But this 12 is there in hex format. हे 12 म्हणजे BCD ला कसं दिसायला पाहिजे, 00010010, पण ते दिसतंय कसं, 12 चा काय आहे, 1010, then 1011, then 1100 असं असतं ना 12 चा. हो. हा सो हा रिझल्ट अक्युमुलेटर मध्ये येतो, विच इज नॉट इन करेक्ट बीसीडी फॉर्म. हे म्हणजे काय येणार, 12 असेल तर हे ए बी सी, हे म्हणजे सी आहे ऍक्च्युअली इन हेक्स फॉर्मॅट, बट यू वॉन्ट अ रिझल्ट लाईक दिस फॉर बीसीडी. So in that case, if you want to adjust this, this instruction is used, right? DA, decimal adjust accumulator. So just mention one line there in DA. DA stands for decimal adjust accumulator. After BCD addition, the DA instruction is executed. After BCD addition, the DA instruction is executed to get the resultant BCD. When DA instruction is executed, it alters the content of accumulator. It alters the content of accumulator as follows. So first, if sum of lower nibble exceeds, right? If sum of, that means see here, this is higher nibble, this one is lower nibble in a number. So if lower nibble result exceeds 9 hex, or auxiliary carry flag is set. Auxiliary carry flag म्हणजे काय, तर इकडून इकडे कॅरी गेल्यानंतर AC flag set होतो, right? From D3 bit to D4 bit, if carry is generated and passed on, then auxiliary carry flag is set. That means if lower nibble is exceeded than 9, or auxiliary carry flag is set, just right, mention over there, or auxiliary carry flag is set, then a correction factor, then the correction factor 06x or 0110 in bracket, right? The correction factor 06x or 0110 is added to sum of lower nibble. It is added to sum of lower nibble. And second condition is if the sum of upper nibble exceeds than 9, if sum of upper nibble exceeds than 9, or carry flag is set, or carry flag is set, then the correction factor again, then the correction factor 06x or 0110 is added to sum of upper nibble, right? Is added to sum of upper nibble. Increment. Increment the content by 1. Increment the content by 1. पुन्हा content mentioned register, right? So register चे content आहे ते. हे important है. Increment or decrement? Increment the content of memory location. Meaning लक्षात घ्यायचं. Increment the content of memory location. म्हणजे काय होईल? Or decrement the content of memory location. So whatever contains over there which is pointed by HL is basically incremented. Since this instruction gives you idea about increment the memory content, decrement the memory content, right? So memory content म्हणजे content pointed out by HL pair. आता परत हे का तर ही 8-bit इन्स्ट्रक्शनच असणार आहे आणि HL तू कन्सिडर केला असता 16 बिट असतो, राईट? सो असं असेल तर 16 बिटच्या केसमध्ये इन्क्रीमेंट आणि डिक्रीमेंट असं असतं, राईट? सो हा एक्स आला inside instruction, that means those operations are 16 bit, right? Increment in instruction मध्ये I आला तर तो immediate data असणार आहे. That means data is there in instruction itself. म्हणजे हे immediate झालं. हे इम्पॉर्टंट आहे. सिम्पल इन्स्ट्रक्शन अशाच असतात. एक्स जर मेन्शन झालं, दॅट मीन्स दोज ऑपरेशन्स आर ऑफ 16 bit, राईट. अरे झालं की. हा, आता तू म्हणतोस ते INX-H. Increment the content of HL pair, right? The DCX-SP. Decrement the content of SP by 1. Increment the content of HL by 1. राईट. आता हे असं असतं, त्या केसमध्ये तो लोअर निबलवरच अफेक्ट करतं, राईट. या केसमध्ये ते लोअर निबलवरच अफेक्ट करतं आणि लोअर निबलचे ऑपरेशन्स कम्प्लीट होत आले तरच हायर निबलला जातो, राईट. सो this is what a basic difference in between INR and INX, right? So this is how arithmetic instructions are work. We'll stop here. Yes. Next group is logical, but those संपणार नाही, right? We'll stop here.